All right. So for section 9.2, we're going to build on what we started in the first two videos. First two videos were all about what happens to a parabola, which is this sort of U-shaped graph. What happens if I change the a value or the c value, which is the number in front of x squared and the number at the end. And today we're going to see what happens if the b value changes, because it's some pretty interesting stuff. Our EQ is how does changing the b value affect the graph of a quadratic function. So we'll take a look at that in just a second. But before we do that, I want to take a look at a couple of ax squared plus c graphs, just to kind of remind ourselves what the rules of those things were. So if I look at this first equation, y equals 3x squared plus 2. The fact that this is a positive 3 tells me that the graph is going to open up. And this plus 2 at the end means the graph was moved up 2. So the vertex should be above the graph, or sorry, above the x-axis. It should be up 2 spots. And so that would lend itself to this graph right here, actually. If we scan all the other graphs, we see that this one starts at 2, but it actually opens down. And that would only happen if we had a negative a value. And then this last graph does open up, but it starts 2 down. This blue graph has been moved down 2 units from the x-axis. So that's not going to match that one. So we have the graph that corresponds with that first equation. If we take a look at this next one, 3x squared, so it opens up, but down 2. We just talked about that's this graph at the very end. The next one is negative 3, so it's going to open down, but it starts up 2. So the vertex is above the x-axis, so it's going to go right here. And then finally, by process of elimination, this last one, negative 3, which opens down, and then minus 2, so it starts down, is going to be that graph right there. So that was kind of what we talked about in 9.1.1 and 9.1.2, those two different functions, or those two different videos talking about how a parabola changes. So what's crazy in the last couple of videos is no matter what you did with A and C, the line of symmetry never changed. That line of symmetry, or sometimes called the axis of symmetry, was always right down the y-axis. It cut the graph in half right down the middle. If you change the b value, that's what we're going to see today, is it not only changes the vertex, but it also changes the axis of symmetry in kind of a weird way. So that's why we saved the b value for last, because it changes the most stuff. So to find the axis of symmetry, to find that line that's going to cut through the middle of the graph and kind of fold it in half for us, there's a rule to find it, and it's always written as x equals, because a vertical line will always hit the x-axis, and vertical lines are just written in the form x equals. And the rule is it's the opposite of b, so whatever the b number is, divided by 2 times a. Okay, you'll hear this a lot. You'll hear negative b over 2a from your instructors as well, but the opposite of b divided by 2a gives me the single number where that line of symmetry will hit the x-axis. So we're going to take a look and see what that means, but you're going to be using this a ton through the rest of this chapter and beyond after this course as well. With parabolas, almost the most important thing is negative b over 2a. So let's take a look at an example of how could I find the axis of symmetry for this equation, y equals 2x squared minus 8x plus 2. So what I'm first going to do is I'm going to label my a, b, and c values. So the number in front of x squared is a. So over here on the side, I'm going to say a equals 2. The number in front of plane x, so the number in front of x with no exponent, is my b value. So it's important that you include the minus sign or the negative sign and call that negative 8. Okay, our b value is negative 8. And then finally, our c value is positive 2. So to find the line of symmetry, I'm going to do the opposite of b divided by 2 times a. Well, if I think about if my b value is negative 8, what's the opposite of negative 8? You could do this, okay? what's the negative version of negative 8. But I like to use that word opposite to basically say the opposite of b is going to be positive 8. So it's just turn the negative number positive or turn the positive number negative. Okay. And then divided by 2 times my a value. Well, my a value is 2. So 2 times 2 is 4. So this is going to become 8 divided by 4. And 8 divided by 4 is 2. So that means that the line of symmetry, if I were to sketch this graph real quick, that means the line of symmetry would go right here. So it's actually shifted the entire graph over to the right a little bit. And the other important part to this, and maybe even more important than the line of symmetry, is remember that on the line of symmetry, the vertex has to show up somewhere. So I know the vertex is going to be somewhere on this orange dashed line. I don't know yet if it's up here. I don't know yet if it's down here. It could be in the middle, but it has to be on that line of symmetry. And that's the next thing we're going to do is we're going to figure out where the vertex is, because that is without a doubt the most important point on a parabola. Okay, but key piece here, to find that that x value of 2, we did the opposite of b divided by 2a, or 2 times a. Okay, so a couple different ways to do this now. This is the exact same equation. So we already know, I'm just going to rewrite it. We already know that the axis of symmetry is going to be at positive 2, because we had 8 divided by 4, which is 2. Now, what's super important about that, the fact that the vertex is always on the line of symmetry means that the vertex, remember the vertex is a coordinate, the x coordinate of the vertex will always match what you just found. So we've found the x coordinate of the vertex. We know it's 2 comma something. And now to find that something, we have to plug the number into the equation. If we have an x value of 2, what I'm going to do is I'm going to go back and replace these x's with 2's. Okay, so now I can type that into my calculator just as it looks. I'm going to show you 2 ways to do this. If you need to rewatch it, I know some teachers have certain ways they like students to type this in. So all I'm doing is I'm typing out the equation, but replacing the x's with 2's in parentheses, and that will give me my y value. Another way to do this, and I like this method because if you are being asked to graph this equation or graph this parabola, it will help you right away, is I'm going to go to y equals, type the equation in that I have, so 2x squared minus 8x plus 2. I'm going to go to the table, which we did in the previous video, so I'm going to hit second graph. And then I'm just going to go ahead and find the x value that I care about. And right now, the x value I care about is positive 2. And if I go here in the table, I see that positive 2 is right there. And the y value that goes with it is negative 6. Okay, so this is a little bit longer of a process, typing it into the y equals. But what that does is it allows us to get all the y values. And so if we want to graph it, we actually already have the points. And I'm going to use this in just a minute to graph a full function. So either way, the vertex we know is 2 comma negative 6. And that is really the most important part to know. If you know where the vertex is for the graph, we can draw a lot of other conclusions from that, but knowing where the vertex is on that graph is super, super important. So we're going to take a look at, this is just steps on how to do the calculator portion where you type in the y equals. Go ahead if you want, if you feel comfortable with it, pause the video now, see if you can find the vertex for these two, and then we'll do a couple graphs and we'll be done here. All right, so to find, oh my gosh, why won't you zoom in? So I'm going to first label my A, B, and C values because I find that's easiest to kind of go off to the side here and keep myself organized. So 3, positive 18, and make sure you include the negative with the 9. Now, the C value actually doesn't matter right now because in order to find the axis of symmetry or the X value of the vertex, I only have to do the opposite of B over 2 times A, which is 2 times 3. 2 times 3 is 6, so negative 18 divided by 6 is negative 3. So what that tells me is the vertex is at negative 3 comma something. And again, my personal preferred method, and I know it's a little bit clunkier, is I'm going to go through and I'm going to type in the equation I have, and then I'm just going to go to the table and find negative 3. So negative 3 I see up here goes with negative 36. And another way, this is kind of next level stuff. Another way you can find, you found the vertex, is the number on either side, the number one above and one below, the Y value, one above and one below, should be the same. So I see negative 33 if I go down one spot, and I see negative 33 if I go up one spot. And that's that symmetry that is built into all parabolas. So we found the vertex, negative 3, negative 36. Here's the first example we have today of when a value is missing. Remember, if there's just an x squared, there has to be some number associated with that, and so that's going to be a 1. So my a value is 1, my b value is negative 10, and my c value is 9. So my x value of the vertex is the opposite of b. Well, negative 10, the opposite of negative 10 is positive 10. 2 times 1 is 2. And 10 divided by 2 is 5. So my vertex is going to be at 5 comma something. Okay. Again, you might be able to do this in your head. Really strongly recommend you use a calculator. Even if you're not doing the y equals version, but you're just typing in the function and replacing the x's with 5s. So I see on my screen down here, 5 goes with negative 16. I'm going to go down just to make sure I have that repeating of the y values. And sure enough, on either side of negative 16, I see negative 15. So I know that I have done this correctly. So negative 16 is my vertex. Okay. Really, the only other thing I wanted to take a look at very quickly is if I asked you to sketch a graph of this, we're going to do the exact same steps. The only difference is in the previous videos, we did negative 2 to 2. We're not going to do that because that doesn't necessarily help. If you graph from negative 2 to 2, your entire picture might look like this, and that doesn't help a whole lot because I don't see the symmetry in the parabola. So what I'm going to do is I'm going to first find the vertex, and we'll go from there. So I cramped a little bit on space here, so I'm not going to list out A, B, and C. But the opposite of B, my B value is 6, so the opposite of that is negative 6. And then 2 times A, my A value is negative 1, so 2 times that would be negative 2. So it tells me my axis of symmetry, or my x coordinate of the vertex, is positive 3. What I'm going to do for that then is I'm going to put that number in the middle of my of the x side of my table. And the reason I'm doing that is because now I know that I will have some points on either side of the vertex, so I'll get to see the bottom or the top of that parabola. Again, to find the vertex, you maybe don't even need to do this step, because if I just type the entire equation into the calculator, I'll have all the y coordinates that I need. So negative 1x squared plus 6x minus 7. Okay, so 3 is the number that I care about. So I see that the y value for that is 2. And then it doesn't matter what numbers you pick as long as you get a couple on either side. So I'm just going to use the next numbers that I see in the table. So after 3 comes 4 and 5, and before 3 comes 2 and 1. Then I'm just going to copy down the numbers that the graph gives me. Or sorry, that the table gives me. so that I can use these points now to graph. So 1 comma negative 2. So again, just a reminder, if you're plotting points, right, you are reading straight across, and those two numbers combine to make a single point. So 1 comma negative 2, 2 comma positive 1, 3 comma 2, 4 comma 1, and 5 comma negative 2. And I can see that I have this parabola shape. It's opening down because the a value is negative. You do not have to label the vertex, but it's good to just keep a reminder that the vertex in this case is a maximum because it's up at the top of the graph. Okay, go ahead, pause. Last thing we got to do before we summarize, go ahead and try graphing one of these things. So here I have the x value of the vertex is the opposite of b over 2a. B is negative 6, so it's going to be positive 6 divided by 2 times a, which is going to be 4. And then that will give me an x value of 1.5. Ugh. Okay, not optimal that we have 1.5 on here. I'm still going to use that. Now, there's a couple different ways to deal with decimals. Right now, the way I have the calculator set up is the table will only show me whole numbers. So instead of going through like how to change all that, I'm just going to manually plug 1.5 in using the other method that I showed you, where I'm just going to replace 1.5. 1.5 squared minus 6. Nope, I can't use x now. I have to actually replace with 1.5 and then plus 5. And that will give me 0.5. So that is my vertex. Now, I am going to use, to fill out the rest of the table, I am going to use the calculator the same way we've been doing. So 2x squared minus 6x plus 5. Then I'm going to go to the table. I know 1.5 is not going to be on there, but I'm just going to use the whole numbers that are close by. So the next two whole numbers after 1.5 will be 2 and 3. And the previous whole numbers will be 1 and 0. So I have 1 and 5 and 1 and 5. And again, I know that I've done this correctly because I should see that repeating value on either side of the vertex. Okay, so I'm going to finish up by graphing this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 comma 1. 1.5 comma 0.5. So it's kind of like in the middle there. And then 2 comma 1 and 3 comma 5. So then I have a parabola that opens up and has a vertex that's a minimum. Okay, so the biggest thing to take from today's lesson is that changing the b value or having a b value changes the axis of symmetry and the vertex. That axis of symmetry is x equals the opposite of b over 2a. So this is important, but that number tells us the x coordinate of the vertex. Okay, so that'll do it for 9.2. We got one more video in the first half of chapter 9, and then we're done.